Sorting for today is rather lengthy in terms of words, but relatively easy in terms of what we're looking for. We're going to be able to define and recognize examples and non-examples of the commutative, associative, and distributive property. Now, all three of these properties should be reviewed for you. However, we're going to be looking at them in a slightly different light today. So the first thing we're going to do is we're going to watch a 15 or so minute video, which will kind of give us some reminders and some examples about commutative, associative, and distributive property. So make sure that you're previewing the notes and what you're being expected to write down while I pull up the video. Let's look over what was given to us in the video, make sure that we have all the right pieces in all the right places. First thing it says, what is a property? So in our video, it gave us some ideas about what a property is. Somebody with a raised hand, what is a property? Mr. Posey.
A property is the ability that a number has.
An ability that numbers or terms or an ability. I'm just going to put this ambiguous things in here. Because today we're talking about operations that have abilities. So things, we're going to call that operations. Maybe it's other types of, math things. But today when we're talking about properties, specifically we're more talking about the abilities that certain operations have. So starting with the commutative property of what and what? Brune. Addition and multiplication. So it didn't give us a definition exactly for us to copy down, but some of us should be able to use our prior knowledge. Mr. Espinoza, what definition do you have for the commutative property?
To be able to move the numbers around in different orders and still get the same answer.
To be able to move I'm going to replace numbers with terms because sometimes they're variables. In a different order. So different with two F's this time. Okay, and specifically this works for addition and multiplication. Which means not subtraction and division. That was an excellent definition. Thank you, Kevin. Examples. Oscar.
A plus B equals
A plus B is equal to So 2 times 1 is the same thing as 2 plus 1. All right. Something's wrong with your example then. Look back down and fix it.
A plus B equals B plus A.
Good. 2 plus 1 is the same thing as 1 plus 2. Other examples. Joseph. Sorry, got a little bit of distraction there. One more time. 3 times 6 is equal to 6 times 3. So that makes us see that this is available for addition, subtraction, or addition and multiplication. Let's move on to associative property. Associative property of Winta? Use some prior knowledge. You know what associative property works for? Addition and multiplication. Somebody with a definition for associative property. Again, this is one that they did not specifically give to us, but we should be able to use our prior knowledge and what was said in the video to create our own definition. William.
Putting parentheses around two numbers.
Putting parentheses around two numbers. Interesting. I think there's more specificity that you could probably use there. I'm going to let Mr. Posey try and make your answer a little bit more specific.
To reduce the amount of work you have to do, you could put one set of parent numbers in parentheses and do that expression, and then you could do the next expression afterwards.
Okay, so I'm putting these two ideas together and I'm still missing one piece. So what I hear Isaiah Williams saying is that if we have a string of addition or a string of multiplication, I can use parentheses to group different parts to do operations one at a time. The one piece I'm missing there is, when can I do those parentheses? Does it matter what sets of things I put in parentheses first? Mr. Posey? No is the correct answer. So, for our definition of associative property, with, actually I'm not going to spell out addition. With addition and multiplication, we can group, and that's using parentheses, any set we want first. So, for example, Oscar.
A parentheses with B, C, and
That's the same as what? Using associative property, how else could I group those things?
A, B, instead of
Yep.
parentheses and C, inside of it.
So in this case, this is like 2 times 3 times 1. I could do the 3 times 1 first, or I can do the 2 times 3 first. So notice the order of the terms is not changing, simply which set we are doing first. That's associative property. That works for multiplication and for addition. So somebody give me an example with addition. Jacqueline? No, for associative. I'm looking for an example using addition of the associative property. So I hear A plus B plus C. Okay, so she's telling me A plus B plus C equals C plus B plus A. Is this an Kip yes or Kip no? Is this an example of the associative property? Is this an example of only the associative property now? What other property has she used in this example? Adriana. Andrea. Commutative. So for it to be a true application of the associative property, we shouldn't be commuting the terms. So, Jacqueline, coming back to you. If I don't commute the terms, how can I use the associative property here? The last example you gave me commuted the terms and used grouping symbols differently. How can we do this example without commuting the terms? Okay, so that's not commuting the terms. That's not commuting the terms. A plus B plus C. Good. Good. So here when we look at this, what she's done here is she's not commuted the terms. A plus B plus C. It's all in the same order. She's just changed which one she's grouping to do first. Moving on to distributive property. Distributive property of what over what? Naomi. Of multiplication over addition. Now, notice it says multiplication over addition. So that means that inside the parentheses should be addition. If there is subtraction inside the set of parentheses, what do you think we're going to do to make it multiplication over addition? There's subtraction inside the parentheses. What do you think we can do to make it multiplication over addition? Renee? Leave, change, switch. So, definition of distributive property. Again, it did not directly give you a definition for distributive property, but you should have been able to create one on your own. Isaiah.
It means that if you have multiplication and addition in the same number system, you should to make it shorter, you should make the addition go. I mean, if it says in the problem to do the addition first, you should put parentheses around the addition, and then have the multiplication outside of the parentheses, which automatically leads to but you have to put parentheses around.
So I have to put the parentheses around there, or they better already be there if I'm going to use distributive property? They better already be there. All right, so we'll come back to that. So he's saying when there is multiplication outside parentheses, when we can multiply all terms inside by the outside number. Examples. Preferably one that used 4 times something. It's okay if you make it up right now. Oscar.
4 times 3 plus 5
Is equal to. Let's go ahead and just write it out as the multiplication. 4 times 3 plus 4 times 5. Now the general example they gave us using just variables was what? Yeah. A, B, A, C like this? Oh, plus. Okay, got it. All right. So one thing that we have to be able to recognize is we're going to be moving forward and we're going to be learning this in such a way that it's going to help us in the next unit make decisions about things that we need to do to solve problems. We also are going to be using it to determine what mistakes are being made along the way. So what we're going to be looking at are some examples and some non-examples of these particular properties, and just making sure we can say with absolute terms why each one is correct or incorrect. So looking at this particular example, what property is being shown here? I'm concerned that only 2 people can recognize what property is being shown here. ECs, what property is being shown here? Okay, so this is the commutative property. It says to write a complete sentence. Is represented here. And a second sentence is to say how we know our answer is correct. So what is it that we see happening from one side to the next that makes us know this is the commutative property? Andrea? All right, so the terms stay the same, comma, they just switch order. Right. So this next step says to complete each example given a property that it represents. So theoretically what should have happened here was this 12 maybe should not have been here, and we would have filled in that blank. So which property is this that's being represented though? Purvey. Associative. Why is this the associative property? Kevin.
Because there's parentheses around numbers and they're not in a pattern like in the top ones.
So there's parentheses around the numbers. Are all of the numbers the same, and are all of the numbers in the same order? 3, 9, 12, 3, 9, 12. All the same numbers, all in the same order. The only thing that is different here is how they are grouped. So here they said, I want to do this addition first. Here they said, I want to do this addition first. That's the associative property. Just changing grouping symbols, all else stays the same. State whether each statement is true or false. Tell which property you use to determine your answer. Give me a kip yes if this statement is true. Give me a kip no if this statement is false. Looking at this equation. Give me kip yes if this is true. Kip no if this is false. Everybody should be responding. Okay, let's start with a raised hand while 2 people are losing their paycheck dollars because they never participated. What property is supposed to be that? Is this supposed to be? Hervey. This is supposed to be distributive property. Distributive property. We see a multiplication outside a set of parentheses with addition inside it. So we know that in distributive property we have to multiply the outside number times all inside numbers. Kip, yes or Kip, no. Was the distributive property correctly applied here? No, what we should see is 5. And in these problems, if you ever say false, you're also going to show me what it should look like. 5 times x is 5x, plus 5 times 12. They forgot to multiply the second term. So this is false. So when it's false, there should be 3 things. Number 1, the property that it's supposed to be. Number 2, the correctly written statement. And number 3, the word false. If it's true, then all you have to do is tell me the statement, or excuse me, which property, and that it's true. Okay? So that's the type of work that we're doing today. Let's flip on over to our key points. Somebody with a raised hand, a key point they think that they have for today. Sadie. So since our aim today is really to be able to define these properties, putting a star next to all of our definitions of these properties is probably a good idea. I take that. Key point. Definitions of our properties. What else? Ms. Posey.
Yeah, that one. If you do that term, you have to and you try to make it longer. You always have to multiply each number by the number how you did in the first one. So if it's like the number that we just did, 5 parentheses x plus 12, then it should be 5x plus 5 12. So it could be equal on both sides.
All right, so he's saying with distribution, you must distribute to all terms inside parentheses. And I've underlined all terms because that's what Mr. Posey is saying is the key point here. Making sure that we get it to all terms inside the parentheses. Any other key points people think we have today?